To Unit 3 on naming compounds. This is 3.2b. Today we're covering polyatomics and covalents. So polyatomic ions. When you have a polyatomic in a formula, these will have more than two capital letters or you'll have parentheses. That's how you know you have a polyatomic. The first name will either be an element or one of your two positive polyatomics. The last name will either be the root-ide system or the name of your negative polyatomic. Polyatomics, remember, have unique names, so we're going to use them when naming the compound. So in the example, CaSO4, BeNO3 2, NH4OH, and H3OF, the first thing you have to do is, if you don't have parentheses, you have to figure out where your polyatomic is. And part of that is just learning the polyatomic list that you've been given. But you have CaS, or is it SO4? Well, if you look at your polyatomic list, it's SO4. So that means the first name is simply the name of the element, calcium, and the last name is the name of that negative polyatomic, sulfate. In the second example, you have BeNO3 2, and you have parentheses, and so you automatically know where your polyatomic is. So this is beryllium nitrate. The third example has two polyatomics together because it's got four capital letters. So this is NH4OH, which is ammonium hydroxide. And H3OF, your polyatomic is the H3O, which is hydronium fluoride. So let's look at the covalent naming rules. One, you have to be sure that you have a covalent compound. It's only going to have two capital letters, but some ionics only have two capital letters too. But both of these elements that are in this compound are going to be non-metals. That's how you know you have a covalent compound. It will have a first name and a last name, just like your ionic compounds do, but covalent compounds use prefixes to show the number of atoms present. Remember, when we bonded them together, we had to tell you how many you were bonding. Now you're going to use that in naming it. So your prefixes, you do need to make a list of these, and these are going to go onto the back of your formula sheet. Your prefix for 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. They're very similar to your polyatomic prefixes or polygon prefixes that you have in math, except for 2 and 4. Those are different in science. The only time we don't use a prefix is if the first name would begin with mono, we don't use it. Otherwise, all covalent compounds have prefixes on the first and last name. So here are some examples. SiF4, N2S3, SCl6, P2O5. We know that these are covalent because they're all non-metals. So when we go to name them, you're going to feel like you're naming a dinosaur. So SiF4 is silicon tetrafluoride. N2S3 is dinitrogen trisulfide. SCl6 is sulfur hexachloride. And P2O5 is diphosphorus pentaoxide. Be sure that you update your formula sheet, adding the positive polyatomic or a negative polyatomic for a last name on ionics. Covalents will use prefix element and then a prefix root-ide. Also on the same formula sheet, remember a polyatomic will have more than two capital letters. Covalents are always two nonmetals, and a prefix shows the number of atoms. Again, you want to have those prefixes filled in on your formula sheet as well. Let's look at naming summary. This is technically 3.2c, but it's just a summary of naming. Remember, when you go to name something, you've got to be able to identify the type of bond, if it's ionic or covalent. If ionic, you're going to have a first name and a last name. It's going to have an element root-ide, a transition with a Roman numeral, or a polyatomic. If it's covalent, again, it's going to have a first name and a last name. It's going to have a prefix element for the first name and a prefix root-ide for the last name. But no first name ever starts with mono, but the last name could. The prefix, remember, is the number of atoms. It's the subscript. Be sure that you update your formula sheet on the steps for naming. Thanks for watching.